This is the screencast for section 5.1, example 2. We're going to do some more estimating of the area under the curve. Now, in example 1, I said that ideally we want to make infinitely many rectangles under the curve because the more rectangles we make, the better our approximation is going to be. And I have a visual for that. If you see here, we've got midpoint theorem, I guess. If we only have 2 rectangles, well, that's not very good, not a very good estimate. We've got this huge gap that we're not estimating and then an over gap that we are estimating and vice versa. It might be close, but it's going to get a lot better the more rectangles we put in underneath our curve. Now, same thing with the left approximation. If I only put 2 rectangles, look at that. That is not even close to what the area under the curve would actually be. But the more rectangles I put in, the closer and closer they make to a smooth curve and therefore a better approximation. So following that logic, I want to come up with a way to be able to do lots and lots and lots of rectangles, but that's not very efficient if you're doing it by pencil and paper. So we've got this calculator program called Area that helps. Now, to do the area program, first thing, you have to put in your equation and set up a good window. So I have in y1 x squared sine of x, and in my window I did -1 4 1 -1 5. I made sure I was in radian mode, and then in my graph you can see a pretty good estimation, or a pretty good visualization of this curve. Now the directions want us to show the graph of f of x equals x squared sine of x on the interval 0 to 3. Estimate the area from 0 to 3. So I can see the area from 0 to 3 quite easily in this window. So now I've got the equation in and the window set up. Now I'm going to quit and I'm going to hit Program, Area. Now it asks me for A. A is the left side that I want to estimate the area, so the starting point, so that would be 0 in our case. B is the ending point, so that would be 3. And the number of subintervals, well, that is determined by this little chart down here. It wants us to do 5, so I'm going to do 5 subintervals. Now you can see the calculator is thinking up here. It's drawing the curve again, and it's drawing those boxes for you as a left RAM, so you've kind of got a visualization of what's happening. Now if you see these tiny little dots up in the right hand corner, that means it's paused. You have to hit enter to make it go to the next menu. Now or next screen. The left approximation would be 5.1548, well, you get it. And now it's paused again, so hit enter. And now it's going to go to, I believe, yep, RAM. So be careful, it does left, then right, then middle. Enter. Now it shows you the right approximation. Enter again. We'll leave you with MRAM, visualization first, and then the numerical approximation. So now, of course, I can be writing all of those down in my chart that the problem gives me. So there are my estimations for just 5 rectangles. Well, then I can repeat that process for 10 rectangles, 25 rectangles, 50 rectangles, 100 rectangles, 1,000, basically any amount of rectangles you want. Try one more just for fun, maybe try 50. I understand you probably don't want to go through all of these during a screencast, but just try one. Make sure you can work this program. The now try problem number 7 asks us for the same thing. So I've already done this. I've put in the function it's asking us to estimate the area underneath, so y equals 2x minus x squared, so a parabola flipped upside down. The x-axis, it wants us to estimate the area between 0 and 2, so there's my A and my B in my program. It did not give me subintervals except for in this chart, so I'm going to need to do 10, 50, 100, and 500. So I just laid out 10 for you. Here's left RAM, 1.32, RAM, and then MRAM. And you can see those numbers reflected here as well. And then of course you can do the rest for 50, 100, and 500. And you can see or you will be able to see in future sections, that the more rectangles we put underneath, the more accurate they're going to get. And you can kind of sense that they're going to get more accurate because look how close L, M, and R RAMs are when you get to 500 rectangles. The closer they get, it's probably going to be a hint of the more accurate you're getting, the level of accuracy you're getting to.